Alright, this video is for section 1.1, and the first thing I want to start with is a little bit of vocabulary. So in this lesson we're going to talk about verbal expressions and then algebraic expressions. And these are really just technical terms for things that you already know. So if I am using words to talk about something, that would be a verbal expression. So if, for example, I say, I have a younger brother and he is 3 years younger than me, that would be a verbal expression. Alright, and an algebraic expression would be using numbers, variables, and symbols. So if I take that phrase that I just used, my brother is 3 years younger than me, you can do this in your head and you already do it already. What we're really doing is we're taking my age, so let's say 15, and if my brother is 3 years younger, how am I going to write that mathematically? Well, it would have to be 15 minus 3, right? Because he's 3 years younger. So that's what we're going to do in this lesson, is we're going to translate between words and conversational language to algebraic expressions, so numbers, symbols, the way that we write things in math. We're just going to go back and forth between the two forms. Okay, so here we have the four major operations in math: addition, subtraction, multiplication, and division. And all of these operations have different ways that they can be said verbally. So I can, using the operation addition, there's several different words or phrases that I could use to represent that addition or plus sign. And you probably already know some of these ways. You probably know several ways to talk about addition or subtraction or multiplication or division. So what I'm going to ask you to do is pause the video here and see how much of this chart you can fill up. How many ways can you think of to represent addition? So go ahead and pause now and fill in what you can of that chart. Just try and think of ways that you've said addition or subtraction in the past. So hopefully you were able to come up with some of these terms, and if not, then you should probably pause again right here and fill in the ones that you didn't get. Alright, but so all of these are ways to say addition. So if I say, I have 5 more than Jimmy, and Jimmy has 2, so I have 2 plus 5 when I write it out. So it's just a different way to say addition. These are all ways to say subtraction. These are ways to say multiplication. These are some ways to say division. What I want to point out, some tricky points. Okay, right here we have the phrase less than. Alright. If I were trying to translate something that had less than, so for less than b, this less than thing means I need to switch the order of them when I write it algebraically. So if I have 4 less than b, that's not 4 minus b. Okay, it's actually b minus 4. Alright, so when you see that less than phrase, remember you have to switch them, okay? And it makes sense if you think about it, because what if I asked you 2 less than 7? 2 less than 7, the number that is 2 less than 7 is 5, so I would have to write it as 7 minus 2 equals 5. If I did it the other way, I would have 2 minus 7, that would be equal to negative 5, but it doesn't make sense with the words because negative 5 is not 2 less than 7. So just remember, when you see that less than, that's a key that you have to switch the order around. Then just a couple other things, other phrases that might be useful to translate. We have here x squared, so exponents and roots. They translated that as a number squared. So why did they say a number? Well, because we don't know what number x is. You could say x squared, right? But anytime you see that phrase, a number, they're using a variable there. So most of the time it's x, but it really could be any letter. So the phrase a number means a variable. Okay, we can say squared, or we could say the square of a number. All right, either of these verbal phrases would work for this algebraic expression. Alright, then we have roots. So this symbol, of course, is square root, so we say the square root of a number because, again, a number is just a variable, so they used x. We can also do cube and cube roots, so a number cubed, alright, or the cubed root of a number. So these are some symbols that you need to keep in mind. This should get you pretty much anything that we need to be able to translate. So let's go look at some examples. Okay, the first examples we're going to translate from algebraic to verbal. So we have numbers and symbols, and we're going to translate it into words. So here I have 3x to the fourth power. I know that if I have a number next to a variable, that means that they are being multiplied. So multiplication is the operation we have here. So we could pick any of our expressions for multiplication. I'm going to use the product of. So I'm going to translate 3x to the fourth into the product of 3 and, okay, because the things that are being multiplied is 3 and then this x to the fourth. So it's going to be the product of 3 and then what am I multiplying 3 by? I have to find a way to write x to the fourth using words. So I'm just going to use the phrase a number to represent x and then to the fourth power. So the product of 3 and a number to the fourth power, that's this thing translated verbally. Alright, now we have 5z squared plus 16. So we have an exponent, we have multiplication and addition. So we got to use several different phrases. So I picked more than to represent the addition. So 16 more than, so plus 16. And then over here I just used simple language that we use all the time, 5 times. So 5 times a number squared, 5 times z squared. Z is a number because we don't know what number it is. Alright. Last example, we have 5 times x minus 4, and the x minus 4 is in parentheses. Alright. Anytime you see parentheses, we're going to use a phrase known as the quantity. Okay, so I translated it as 5 multiplied by the quantity. Anytime I see this phrase, the quantity, I know that what comes after it has to come in parentheses when it's written algebraically. Alright, that's what that phrase means. So it's 5 multiplied by the quantity, a number minus 4. X is a number, we don't know what number, so it's a number minus 4. Right? Anytime we have parentheses, we need to use that phrase, the quantity, because it means the 5 is multiplied by the whole thing, not just 5 times a number. Okay, now I'm going to have you pause again and finish the rest of those examples, and then we will go over them in class. Hopefully you were able to get an answer for the rest of the last set of examples, and now we're going to look at these. Now we're going to go the other way. We're given a verbal expression, and we're going to write it algebraically. Okay, so a number t, right, so now they're telling you what variable to use. They're saying use t. So a number t more than 6. I know that more than is what operation? It's addition, so I have t more than 6. Okay. Now, remember we said that phrase less than, we would switch the numbers. Do you have to do it for more than? It doesn't really matter, okay, because if I wrote it the other way, 6 plus t, remember, what do we know about addition? It's what we call commutative, which means I can change the order of an addition problem without changing the answer, okay? So 2 plus 4 is the same thing as 4 plus 2. So when you have the more than, you can switch the order if you want, but you're still right even if you don't, because addition order doesn't matter. Alright, now we have 10 less than the product of 7 and f. Okay, so we've got less than, I know that's subtraction, I've got the product, so I have multiplication, I got all kinds of stuff going on here. Okay, now remember, for less than, we do have to switch the order. So if I have 10 less than something, I know it's going to be something minus 10. So the minus 10 has to go at the end. And that something is the product of 7 and f. Anytime you have product, quotient, sum, all of that stuff, they're going to use the word and. Alright, so the and tells you the two things that are going to be multiplied. It's the product of 7 and f, so I'm multiplying 7 times f, and I can just write that as 7f. Last one that I'm going to do with you, the quotient of 2 times a number and 6. So again, I have to find that word and. So what two things am I dividing? I'm dividing 2 times a number divided by 6. 2 times a number, they don't tell me what number, so I can pick any number I want. I'm going to pick 2x. Okay, and it's going to be divided by 6. Now, you're used to seeing division probably written with this symbol. That's okay, but we really want to get away from that, because as we start to do more things, this symbol is going to get confusing. I really would like you to get in the habit of writing division as a fraction. Okay, so 2x over 6, that's how we would read that probably, but really it means 2x divided by 6. So the quotient of 2 times a number in 6 is 2x over 6. Alright, what I want for you to do, finish the rest of those examples on your own, and we'll go over the answers. Then remember, at the end you have your little summary activity. This time you're going to put bulleted information that would help you to teach this lesson to somebody else. So go ahead and finish the examples, do your summary activity, and then we will go over stuff in class.